Hey guys, welcome back. It's Silver Surfer again. So I just want to do a video on fancy serial numbers. And this is going to be a two-part video. This first one will kind of talk about the probability here and what it exactly is and how difficult this stuff is. And I really want to do this as I've been collecting for probably about a year now and strap searching for about the same time. And I've learned a ton of information, and I really kind of underestimated how challenging this hobby actually is and how powerful these numbers really are. When you think about it in odds and in terms of probability and stuff like that, it's pretty fascinating. So I hope that this video reaches somebody out there. And if you maybe not are turned into being a fancy note collector, at least that you have some interest and understanding of what it is that we do and are looking for. So anyways, let's go ahead and get started here, okay? Very important to start with. We know that the serial number on money, currency, if you would, notes is an 8-digit serial number. They start from sometimes, most of the time, they'll start all the way at 00001, and up until 1985, they printed the lower denominations up to 99 million and some change here. So that leaves us with 10 different digits to start with, okay? Keep that in mind, very important. So let's get the two tough ones out of the way. Sorry for the shake there. First is a solid serial note. So we know that there's 10 different digits, but the zero there's never released. All zeros is going to be a prototype that's left with the BEP and is usually put on display at their lobby museum. So that leaves us with 9 total possibilities. Okay, that means out of 100 million, you can get this will occur 9 different times, okay? So if you divide 99,999,999 by 9, that gives you 1 in 11 million, 101,101 odds of that actually occurring. And so not very good odds, if you would, but an example would be 55555555 for a solid serial number. All right, you with me? Next is a ladder pattern here, okay? This is basically either ascending or descending, however you want to look at it, from reading from left to right. And so it can be 0, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, or 2, 3, 4, 5, 6, 7, 8, 9. Once you get past that, you're going to go back to 0 on the end of this digit, and it will not be a ladder pattern. It would be 3, 4, 5, 6, 7, 8, 9, 0. And that's not a ladder. So there's 3 possibilities of ascending, and then there's 3 possibilities of the opposite, which would be 9, 8, 7, 6, 5, 4, 3, so on and so forth, the other 2 possibilities. So that leaves a total of 6 out of the 8-digit serial number printed up to 99 million, okay? So if you divide that by 6, that gives you 1 in 16,666,666 odds of finding one. A lot more rare than even a solid serial note, which is also why the price reflects that. And here's an example I did for you guys. 0, 1, 2, 3, 4, 5, 6, 7. That's an ascending. A descending would be 7, 6, 5, 4, 3, 2, 1, 0. All right, so these two you'll probably never find in circulation. It has been done. People do it, but there's money carriers and armed vehicles that work with dealers and stuff in America and overseas and pull it straight from the strap when they transport it and then sell it to the dealer who turns around and sells it to you and I for more expensive. Anyways, what you can find is some of these things right here, and that's why I highlighted them, specifically the binary, the radar, and the repeater. So binary in computer terms is all zeros and ones would be technically. But most fancy serial note collectors will determine a binary as any 2 digits, okay? And so what are the odds of getting a binary? Well, basically we know 2 out of the 10 digits. You have to have all 2 of the same digits. Doesn't have to be in any pattern, just only those 2 digits. So that's 20% chance of getting that on the first, on the second, another 20% chance on the third, another 20% chance, so on and so forth. So if you multiply that all together, that leaves you at 256, all right? You minus that by 2, and essentially you're omitting the 2 solid serial numbers because we don't want to include those in our calculation down here. That would leave you with 254. You do some fancy combination equation, and you'll come out with 11,430 possibility number of occurrences that occur in a 99 printing million. Again, remember, this is a little overzealous here. We only go up to 96 million, so it's actually a little less, but for simplicity purposes, we'll leave it at that. So that's a 1 in 8,749 chance of getting that. So I have found a bunch of them. Here is my latest one I actually found that I can show you guys. So 77337773. That's all 2 different digits, as you can see. So really, really cool there. So, yep, you can find these definitely out in town. The next one we're going to talk about is a radar here. So a radar is one of my favorite type of serial numbers. It basically reads the same forward as it does backwards, all the digits. So if you understand that, then you know basically you can take the first 4 digits have to read the same as the last 4 digits. So that means really you only have the first 4 digit possibility because it'd be the same as the last 4 digit possibility, right? And we know that we have basically 0001 to 99,000 or 9,999 different ways that this is printed in 4 different digits. So that leaves us with really 9,999, but 9 of those would be also solid serial notes. So we minus 9, that gives us 9,990 possible chances of doing that. And the same thing goes for a repeater. Repeater would basically be the first 4 digits repeated for the last 4 digits, okay? And I'll show you guys an example here in a minute too, but it's the same exact odds because you're using the same exact first 4 digits and or first last digits have to match, okay? So again, 9,990, when you minus the 9 solid serial notes, that leaves us about 1 in 10,010 possible choices of that happening. So here is an example of a radar, one of my favorite radars I picked up. Check that thing out. And this is also a binary radar, guys. 2 digits, zeros and fives, and you can see the radar is 0005. And if you read it backwards, it's 0005. The same first 4 digits are read forwards as they are backwards. That's a radar, one of my favorite notes. And then we'll show you guys another repeater that I picked up here. This one I traded with Dustin, and this is another binary, and it's also a repeater, 4442 and 4442. So you see the difference there. The repeater has to read the first 4 digits the same as the last 4 digits going the same direction, but the radar has to read the first 4 digits have to be the same in the opposite direction, basically. But the odds are the exact same, 1 in 10,010. So pretty cool there, guys. All right, moving on to the next, getting a little bit more challenging here. These ones, I start them because you can potentially find them. They're just a lot less likely, and I've yet to actually find one in circulation. One is a 7 of a kind. So 720 ways or occurrences in a 99 million. How do we get that number? Well, basically the way it works is that there's 9 digits. If you take that you have to have one of them the same, right? So say we're going to use a 0, all zeros, and then this last digit and the first digit with all the different possibilities doesn't actually, take that back, not the last and the first. Basically you have to have all the same of the 10 different digits, right? So that gives you 9 different single number that you're changing out of the 7 different possibilities. And when you multiply that 9 different digits times the 8 different placeholders of an 8-digit serial number, that's 72. And that's where that number comes from. So there's 72 possible ways, right? But we know there's a total of 10 digits. And so there's 72 possible ways per each digit. So if you multiply 72 times 10, that gives you 720 occurrences that this happens within an 8-digit serial number if it's printed up to 1 million, or excuse me, 100 million. So again, divide the 99 million and change by 720, and that gives you 1 in 138,888. And I have an example of my most recent one as well, which would be, again, 5s and zeros, as you guys may have known or picked it up here. I'm a big fan of 5s and zeros, and I got some more to show you in part 2. But this one, 55, 550, 555. All one digit and or all 7 digits with one that is not that digit. So pretty cool. And then make it a little bit more rare because now you have 7 in a row, so you still have 7 digits you're using. But the difference is that as I was beginning to talk about last, is that you only have 2 ways of doing this, either by changing the first or the last digit. So you have 7 this way, and this number will change 9 other times because we have a total of 10 digits, so we're using one of those. So you're going to have this number change 9 other times, okay? Or you can have this number change 9 other times, and all this digit be the same as well. So that leaves you with a lot less possibilities, specifically 18 ways per each number. So you'd say you had 000 right here. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 9 that way, and then you can have 1, 2, 3, 4, 5, 6, 7, 8, 9 in the first digit with all these being 0. So that's 18 possible ways per the 0 digit, okay? And we know there's 10 digits, so 18 times 10, right here, that's 180. So quite a bit less, quite a bit more rare to get this, right? And again, divide 999 million by 180, gives you 1 and a little over 500,000 there, as you can see the number. I don't have a 7 in a row yet, but an example would be 55, 55, 555, 2. Pretty cool, huh? All right, so now moving to more of my favorite kind of types of fancy serial notes. I do love the radars, but to get a little bit more pizzazz, if you will, here's a double quad. These are all going to be the exact same rarity, guys, exact same rarity. And again, this has to deal with the first four numbers and the last four numbers being basically the same repeating pattern, except in a double quad, it's the first four will be either one way, it'll be all zeros and all ones, or all zeros and all twos, all zeros and all threes, all zeros and all fours. And so basically, not to get too much into the math here as I'm running out of time, but what would essentially happen is that you're going to have 9 different ways of doing this with each of the different numbers, okay? And there's 10 different digits. So 9 times 10 is going to be 90. Actually, it's 99 if you include the solid serial notes, which technically a double quad is. If you had a solid serial, that is also a double quad, right? Because that's the first 4 are the same and the last 4 are the same. That's what a double quad is. So technically a solid serial note fits into that description, but we don't want to add and include that. So anyways, that would be 90 total occurrences. If you divide 99 million by 90, you're going to get 1 in 1,101,101. And an example would be 00005555. Super repeater. This one's basically where it's all digits are repeating the same, the 2 digits only though, right? So it's 01010101, 020202, so on and so forth. It could be 23232323, etc., etc. Again, if you break it down by the first 4 digits having to be repeated by the same last digits, and you know that a super repeater entails the first 2 being the same as the next 2, then you're going to get the same odds here, right? It's going to be, there's only 9 different ways per each number to do that. There's 10 different numbers. You multiply that together, that's going to be 90. So once again, 1 in 1,000,000 and some change. And an example would be 05050505. Next, we're going to skip the super radar and talk about that. We'll do that last. But basically, a radar repeater is essentially the first 4 digits are a mini radar. Excuse me. The whole number is a radar, and it's also a repeater. So I said a radar reads the same forward, the total serial number as it does backwards, and a repeater reads the same first 4 digits as the same last 4 digits. So it's 01100110. That would be a repeater. But look at this, 01100110 going backwards, that's a radar. So it's both. So again, the odds of this, same as before, 9 different ways of doing this with 10 different digits, so 90. 99 million and change divided by 90, you get the 1 in 1,000,000. And I do have an example of that, guys. So I wanted to show you. So take a look at that one. 5005, 5005. You read it backwards, it's going to be 5005, 5005. So it's not only a repeater, but also a radar repeater. One of my favorite notes. And to give you guys a little bit more pizzazz here, which us fancies really like, us fancy serial note collectors, it's on the 5th digit. Excuse me, 5th district. How cool is that, huh? So 5's on the 5th. Love it. That's just super, super rad. And I'll show you a treat in the next video. I actually got a matching serial number with this, so really, really cool. And lastly, my favorite, the super radar. So same odds as before, and essentially the last 2 digits will be the same with the 6 digits in the middle, all the same, all right? And it has to read the same forward as backwards. That is a super radar. The odds are all the same as I mentioned in these last couples. And here will be an example of the Big Mama Jamma that I saved until the very end. Take a look at that bad boy, guys. I freaking love that one right there. Look at that, 5000005. Makes it seem even much more incredible as a zeros centered super radar is a very, very desirable note. You can have, 511111115. You can have 533333335, or you can have 355555553, whatever the case is. But to have the ones with zeros in the middle are very desirable, and they definitely command a premium. And lastly, what makes this thing even more cool, check the block number out. It's a true radar with the same matching blocks, huh? B and B. So B5000005B. B5000005B. So I hope I made you guys' head spin by now. If I haven't, watch it again. All right, guys. Catch me on the next video that's going to be posted just right after this on my update of my fancies.